Now let's take a look at problem number 4. I do not have a GCF because there's a 1 here and this doesn't have a y, so nothing in common with my variable either. So I am ready to jump into factoring. I notice that it has 3 terms, so that leads me to immediately saying that I'm going to be using Xbox. So I have an Xbox set up here and I'm going to fill it in. Remember that A times C goes in the top, so that's going to be 1 times negative 48, negative 48. B goes in the bottom, negative 13. Looking for factors of negative 48 that add to be negative 13. That means that the bigger factor that I write needs to be the negative one in order for this to be negative. Whatever the sign is here is going to be the bigger factor, and I always write my biggest factors on the right hand side. I'm going to say 1 and negative 48, 2, negative 24, 3, negative 16, 4, negative 12. The last one's going to be, let's see, 5 won't go in, but 6 will, and that'll be a negative 8. I need to figure out which of these is going to give me negative 13 when I add them, and that would be 3 and negative 16 right here. So that's what I'm going to use to solve my X puzzle. And then those become 2 of the pieces that I write in the box. Here is where I need to be a little bit careful when I start writing things in the box. Remember that this is the format that we use for quadratics, things that have a squared on them, but this doesn't. This has a 4th power. So instead of writing a y when I write my 2 factors, I need to double that. I need to write a y squared in order to match this middle term here. Whatever power is on this middle term is what needs to go in these 2 boxes. The other 2 boxes, still my first term, the one with the A on it, and my C term. So let's look at what that's going to look like. If I fill in this first box, it's going to be with a y to the 4th, and the bottom right will be a negative 48 from my original problem, the first and last terms. Now I need to fill in a 3, but with a y squared, a negative 16, but with a y squared. Why? Because it's this B term right here that dictates the power on our variable. Now it's just a matter of finding a GCF between each line and then each column. So if I look at the first line, I see a y squared. If I look at the second line, I see a negative 16. If I look at the first column, I also see a y squared. And if I look at the second column, 3 will divide into 48. 3 will be my GCF. So now I'm ready to rewrite my factors over here on the left where I have some room. I'm going to say y squared plus 3 and y squared minus 16. Now I want to look at each of these factors individually. Y squared plus 3. I know that if it's 2 terms, I'm looking for perfect squares or perfect cubes, no matter what. 3 isn't either of those because it's prime. So I know that there's not going to be a way to factor this particular factor any further. So I'm going to say that we can't factor that one. But I see that I have a y squared and a minus 16 here. These are both perfect squares and I have a negative between them. So remember that we would use difference of 2 squares there. Difference meaning negative, and I have 2 perfect squares. We've already done that a couple times, so you should be becoming familiar with it. Let's go ahead and rewrite this. Y squared plus 3 coming along for the right at this point. But we can factor y squared minus 16, the square root of y squared is y. The square root of 16 is 4. Remember, 1 gets a plus and 1 gets a minus. We now have this, which we already decided we couldn't factor further. These 2 are linear terms, meaning we have an exponent of 1. And so we know that we are done and we can box this as our final answer. Let's also go ahead and make ourselves a note here that this was difference of two squares so that you'll remember what we did here. Difference of two squares.